Okay, so I hope you all got on okay with the differentiation yesterday. So before we move on to anything a little bit more advanced, we'll just recap on the differentiation we did yesterday. So yesterday we were differentiating terms like so. Okay, so we have 2x to the power of 6 minus 5x squared plus 2x plus 5. Okay, so using the method we learned yesterday, so power multiplied by the coefficient and then minus 1 from the power. So 6 times 2 is 12. 6 minus 1 is 5. 2 times minus 5 is minus 10. 2 minus 1 is 1. Now, you don't have to write the 1 there, we usually don't. So then 1 times 2 is just 2. And then 1 minus 1 is 0, so you'd have x to the power of 0, which is just 1, so that cancels out. And remember what I said, coefficients always cancel out. So this now dy dx is 12x to the power of 5 minus 10x plus 2. And that's it differentiated. Okay, so just to recap, 6 times 2 is 12, 6 minus 1 is 5. 2 times 5 is 10. Minus 1 from the power leaves you with 1. 1 times 2 is 2. 1 minus 1 leaves you with 0 as a power, and the power of 0 is 1, so the x cancels out. Now, today we're going to look at some harder terms or indices that we will be differentiating as well. Okay, so we've got fractions, we've got surds, and I just want to show you, so I'm going to go through each of these examples and just show you how we can go about differentiating them and what tricks we can use. So the first one, we've got a fraction. Okay, so when you have a fraction, we try to bring the denominator up and then differentiate. So with all these examples, you're going to have to rearrange what you're given first before you can differentiate. So here, when you've got a fraction, you want to try to bring that denominator up, but as we bring it up, it turns to a minus. Okay, so that x to the power of 2 comes up as x to the power of minus 2. Okay, now that it's out of fraction form, we can then differentiate. Okay, so doing exactly what we did up here, minus 2 times 1. Okay, so there's no coefficient written there, so we assume it's 1. So minus 2 times 1 is minus 2x. Minus 2 minus 1 more gives us minus 3. Now be careful that one. So minus 2 minus 1 further gives us minus 3. Now, that is a differentiated. However, when we have a negative power to x here, in questions where we're expanding more, it's not going to be very useful to us. We always want our powers to be positive. Okay, so now we're going to do the opposite of what we did up here. So we brought the denominator up, made it a minus. Now to get it back to positive, we're going to bring that denominator down. So the minus 2 is the multiplier coefficient, it stays on top. X to the power of minus 3, bring that back down to the bottom where we got it in the first place, and that turns into a positive 3. And that's your answer then. Minus 2 all over x to the power of 3. Okay, so we'll do it again here with this one. So I've got 1 over x to the power of positive 9. Okay, want rid of the fraction before we can differentiate. So I'm going to bring that x to the power of 9 up and it becomes x to the power of minus 9. Now, this is 1 on top, so if that was a different number, you'd have to be writing it there, okay? But for 1, anything times 1 is just 1. So, again, our differentiation from yesterday, so minus 9 multiplied by 1 is minus 9. Minus 9 minus 1 more gives us minus 10. Okay, so technically, it's differentiated, but we don't want that minus power. Okay, so we're going to try rewriting it now. So minus 9 all over, bring that x to the power of minus 10 down, becomes x to the power of positive 10. Okay, so you can bring x and its powers, move it from denominator up to the top and back down again. However, you just have to remember, you change its sign. So when it comes up, it becomes a minus, and to bring it back down, it turns into a positive. And then that's more helpful for us as we get further into the chapter. Okay, so if you're given a fraction of powers, try to bring them up, then differentiate. You can't differentiate the fraction.